5.5, we will not get finished. It's a 2-day thing. We're going to apply the remainder and the factor theorem. So, first of all, y'all need to pay attention, really close attention to that. What we're doing is not hard, but it's kind of different and a little weird. Okay? So, we're going to do long division of polynomials. Okay? Long division of polynomials. So the first thing I want you to do is, let's just talk about long division. Okay? What grade were you in when you learned long division?
I don't even know if I
4. You're in the 4th grade when you learn long division. Okay? So let's just make sure that we remember some of those 4th grade skills. Okay? 4 goes into 967. Let's talk about some things. What's this number out here called? Very good. He is. He is the divisor. Divisor. Oh, outside. He's outside the house. Guess what this is? The dividend. Guess where the dividend is? He's in the house. All right. Now, whenever you get your answer, it goes up here, right? What's he called? Quotient. Very good. The quotient. Okay, so let's do it really quick. How many times does 4 go into 9? Twice. Now what do? You do what? Where did you get 8? You multiply. See, I ask you what to do, and y'all say subtract 8 from the bottom. Do we always subtract 8 from the bottom? Where did 8 come from? You multiply. What's 2 times 4? Now what do we do? Subtract it. What's 8 from 9? And now? Bring down the 6. And then what? You do it all again, right? You start all over again. How many times does 4 go into 16? And then you multiply. What's 4 times 4? And then you subtract. And what do you get? 0. And bring down your 7. How many times will 4 go into 7? 1 times 4 is 4. And when you subtract, you get 3. What is that called? The remainder. Okay? The remainder. Now, do you remember how you used to write the answer? You would say, oh, this is 240, no R, 241 and 3/4. That's exactly. You took the remainder and you put it over the divisor. 241 and 3/4. That's what we're going to do. Okay? I'm going to write R. Okay? We're going to say that it goes into there. 4 goes into 967, 241 and 3/4 times. Okay? Now, can anybody give me the algorithm for division? Like, what's an algorithm? It's just a formula. That's how you do something. It's just a formula. Okay? So you're saying that you don't know, but I think you do know. So let's do this. 4 goes into 9. How many times does 4 go into 9? 2 times. 2 times 4 is 8. Subtract and you get a remainder of 1. So what's the relationship? How did you used to check and make sure your answer was right?
Multiply the number on the side, the number on the top, and then add it by the number on the bottom.
That's right. Y'all multiplied these two. 2 times 4 is 8. Plus 1 is 9. That's the algorithm. Okay? So the algorithm says, what? You take the divisor, and what do you do with it? Divisor times the quotient plus the remainder. Very good. Equals the dividend. That's the algorithm for division. If that's not true, you're wrong, right? Everybody agree? You messed up. You didn't get the right answer. You did something wrong. All right. So this is the same thing that we're going to do, except instead of doing numbers, we're going to use polynomials. Okay? But it's all the same thing. All right. So let's try one. This is example 1. It says divide f of x is equal to 3x to the fourth minus 5x to the third plus 4x minus 8 by x squared minus 3x plus 5. We're dividing polynomials by polynomials, okay? Long division. So the first thing that you have to know is who goes in the house and who goes outside the house, right? Who's my dividend and who's my divisor? Okay, so the first one is my dividend. This one right here. Now look, wait, before you write it down, let me make sure that you understand something. It's going to be a lot better if you'll represent all your powers. We don't really know right now if I need them all, but if I don't need it and it's there, I just ignore it. But if I need it and it's not there, then it could cause an issue for me, okay? So what am I talking about? Who's not there? Yeah, 4, 3, 2, there's not an x squared. So I'm going to put my 0x squared in there where it belongs, okay? So 3x to the fourth minus 5x to the third plus 0x to the second plus 4x, x minus 8. Okay, and then the dividend is this number. The divisor is this one. X squared minus 3x plus 5. Okay, so now I'm going to show you how to do it. Now, guys, listen to me. There's lots of ways I can say something, okay? I can find a way to say this one that'll make it easier for you. Like, really, I'm doing this. How many times does x squared go into 3x to the fourth? And you could go over here and go, well, I don't know. I can't do that. So I'm going to go 3x to the fourth divided by x squared. How many x's can you take out? 2. So 2 here and they're all gone. 2 here and I'm left with 2. So what's the answer? Okay, but watch this. If I asked it this way, couldn't you tell me the answer? What do you multiply x squared by to get 3x to the fourth? Isn't that a whole lot easier? Okay, so that's how we're going to say it. We're doing the same thing, but we're going to say it that way. Okay, now we're going to be really orderly. And all of our x to the fourths are going to go in this column. All of the x to the thirds will go in this column. All the x squareds are here. All the x's right here. And all the constants or plain numbers, they all go in this column. Okay? You have to keep them in the right column. So, I'm going to ask you again. What do I multiply x squared by to get 3x to the fourth? Where does it go? Yeah, above the 0x squared. 3x squared. And now what do we do? What did you do on the number? You multiplied, right? You multiplied. So that's what we're going to do. I said it's the same thing, so we're going to do it. We're going to multiply. What's 3x squared times x squared? So he goes here. 3x to the fourth. But y'all, you have to keep multiplying. You can't just pick and choose who you want to multiply by. Okay? What's 3x squared times negative 3x? Negative 9x to the third. Very good. Keep going. What's 3x squared times 5? Plus 15x squared. Okay. Now what do? Now we subtract. Now watch this, okay? Because you're subtracting that whole thing right there, which is going to do what? Yeah, he's going to change everybody's sign. So here's what we do. Instead of saying we subtract, we say we change everybody's sign, and then you add. That way you don't make a mistake, okay? So I change his sign, and his sign. Now, what happens to the first two? They cancel out. Now, let's think about that, because listen to what I said. I said, what do you multiply x squared by to get this? I got it, and then I changed its sign. Will the first ones always cancel each other out? Yeah, y'all, that's a check. If your first ones don't cancel out, you made a mistake somewhere, okay? Because I said, how do I get it? And I changed the sign. When I add, they should always go away. What's negative 5x to the third and a positive 9x to the third? 4x to the third. What's 0x squared minus 15x squared? Okay? And now what do we do? Yeah, you start all over again. You just do the same thing. What do you multiply x squared by to get 4x to the third? Okay, so I'm going to say plus 4x. And then I'm going to multiply. What's 4x times x squared? Say it. 4x cubed. What's 4x times negative 3x? Perfect. What's 4x times 5? Very good. And now what are you going to do? Change all your signs. He becomes a negative, he becomes a positive, he becomes a negative. Be careful when you have to change it like this. These are the ones that are easy to make careless. Have you already seen a whole lot of places you can make careless mistakes on? That's going to be your most dangerous thing in this stuff, okay? So you got to stay on point, all right, and be paying attention. What happens to these first two? All right. What's a negative 15x squared and a positive 12x squared? What kind? What's 4x minus 20x? Negative 16x, and then bring down your minus 8. And then we start all over again. Well, you multiply x squared by to get negative 3x squared. And then I multiply. What's negative 3 times x squared? Negative 3x squared. What's negative 3 times negative 3x? Positive 9x. What's negative 3 times 5? And now what do I do? So, positive, negative, positive. Alright, 3x squareds cancel like they're supposed to. A negative 16x and a negative 9x make what? A negative 8 and a positive 15 make a 7, positive 7. Alright, are we doing it again? Why not? How do you know?
Well, I mean, you're not done, but
How do you know you're done?
I don't know.
Yeah, y'all, when this exponent right here is bigger than this exponent, you're done. Okay, so that's how you know when to stop. So, my answer, 3x squared plus 4x minus 3, what?
Negative 25x plus 7 over x squared minus 3x plus 5.
Yes or no?
No.
Why? What's wrong with it? Yeah. Y'all listen to me. If you pull this negative sign out front like that, that's a minus sign, right? He's a minus sign. What's that minus sign in front of this fraction do to that whole top? He changes all the signs. And while the opposite of this positive 25x might be negative 25x, the opposite of a positive 7 is not a positive 7. Okay? So if you're going to pull that negative sign out here, what do you have to do right here? Yeah. You're going to have to change that. Or, look, people, if you want to do it like this, I'm okay with that. Can I just write it like this? Are those the same thing? Yeah, sure are. Okay, so either way you want to write it, just be sure and don't just slap your little remainder up there on the top, and whatever sign he has in front, you carry it up there. Okay, so anybody got a question? Okay, so now I'm going to give you one, and I want you to work it. Here's yours. 2x to the 4th plus x to the 3rd plus x minus 1. We're going to divide it by x squared plus 2x minus 1. You have 2 minutes. 2 minutes. You set it up and divide it out. Be very careful. Don't be careless. Alright, did y'all get it? These are your two answers. Okay, does anybody have a question? Nope, everybody okay? Right here? Right here? I said, what do I multiply x squared by to get negative 3x to the third? Right here? It's the same way. You're gonna remember how you came right here. Okay.
Okay, so
It's do the same thing. What do I multiply x squared by to get negative 3x to the third? Negative 3x. And then you multiply it, change their signs, and then you add. Then you ask yourself, what do I multiply x squared by to get 8x squared? Okay? So you just keep doing the same thing. Anybody else got a question? Nope. Okay, let's try another one. Are you ready? Here's the next one. This time, I'm going to go ahead and set it up for you, okay? So, under the house, I'm going to put 2x to the third plus x squared minus 8x plus 5. And we're going to divide it by x plus 3. Okay? So you do it real quick. Y'all got it? What'd y'all get for a remainder? Negative 16. Okay? Alright, that's my remainder. Now, if I set this little this little divisor right here, if I set him equal to 0, what would x be? Okay, so let's find f of negative 3. Let's take this polynomial right here and find f of negative 3. Well, that'll be 2 times negative 3 to the third power, right? Plus negative 3 squared minus 8 times negative 3 plus 5. Okay, so what's negative 3 to the... Y'all, when you raise a negative number to an odd power, what kind of answer do you always get? A negative, right? So this is 2 times negative 27. When you raise a negative number to an even power, what kind of answer do you always get? Positive. So this is 9. And then negative 8 times negative 3 is plus 24. And then plus 5. Let's see. 2 times negative 27 is negative 54. Is that right? And then there's 29. And 29 and 9 make 38. Let's see. What's a negative 54 and a positive 38? Negative 16. Huh. Same thing we got over there. Did it bring them back any memories? Is there another way to do it? Come on. The teacher taught you another way to do this. No? Remember how to find this number right here? There you go. Synthetic division. We started off calling it synthetic substitution, and then I said, hey, y'all, down the line, they're going to call this synthetic division. So, I mean, you know, you can call it what you want to. So, could I use synthetic division and find this negative 16 again? All right. So, if x plus 3 is a factor, then the root's negative 3, right? Remember, this was on the porch instead of in the house. You had to make sure that every exponent was represented. 3, 2, 1, 0. And then you write down their coefficients. 2, 1, negative 8, and 5. Remember what to do? Bring the 2 down. Good job. And then what? Multiply. 2 times negative 3 is negative 6. And what? Why am I adding here? And in division, I really subtracted. Yeah, you changed the sign. I changed it. That's what that did. So that took care of that. So negative 5. What's negative 5 times negative 3? What's a positive 15? Come on, Ken. Positive 15 and negative 8? Positive 7. What's 7 times negative 3? Negative 21. Negative 21 and 5? So there's that same negative 16 that we got in both of those places.
When did you change the sign?
When it was x plus 3, and we said negative 3. Okay? Now, so that's pretty good, right? But is there any way that I could find the quotient? Where are they, Marissa? Yeah, there it is right there, guys. Look at that. 2, negative 5, 7. 2, negative 5, 7. Oh, my word. So, I mean, and look, think about this, okay? If you take an x to the third and you divide by an x to the first, what will you get? If you take an x to the third and you divide by an x to the first, what will you get? Okay, so since I'm dividing by an x to the first, now this is always going to be 1 degree less than this one. That's why it's 2x squared minus 5x plus 7x to the 0. Pretty cool with my remainder right there. So minus 16 over x plus 3. That's pretty nice.
Does that work with like all numbers?
That it doesn't. And that's why you have to learn long division. Because guys, look, it's not going to work with this guy.
Well, I mean, like, we'll work with, say, we're in 4th grade, we don't know about polynomials, we'll work with those numbers.
Well, you're not dividing them into a polynomial. You're not going across a bunch of terms with x cubes, x squares, x's, and constants. Okay? You're just dividing it into a number. Okay? So all we've done on synthetic division is we've just taken out the fluff. I know this is an x cubed, an x to the second, an x to the first, and an x to the 0. Okay? He's going to be 1 degree less. I've just taken out the fluff. I'm just working with the numbers. Okay? So, is it faster than this way right here? But it only works when you're dividing by a linear binomial. That means it can only have how many terms? Linear binomial. 2 terms and only an x to the first. That's linear. Okay? So it won't work here. You can't do it by synthetic division. And that's why you have to know long division. Okay? You can't use it here. You can only use it in ones like this. Okay? But that's pretty cool, isn't it? Alright, so here's what some of the kids said. Hey, Miss Davis, so can I just use long division all the time? Yeah, come on. Don't die on that hill. That's crazy, people. Don't be fighting that battle. Look, I'm going to give you some problems, and essentially you're going to end up doing this about 8 times during one problem. Do you want to do that 8 times during one problem? No, you'd be insane. Okay? So you need to know synthetic division, and you have to know long division. Okay? So that's all we're doing today. I'm going to hand out your worksheet, and I'll tell you what, we'll just talk about the first one. Hi, Rick. Sure. And we're going to talk about number 1. The reason we're going to talk about number 1, look at number 1 on the worksheet. What are a bunch of kids going to say? It's long. It's got a lot of words in it. I'm not working that problem. Okay? Hey, how many blanks are there on number 1? How many? Tell them. 8 blanks. So that one problem is like the same as 8 other problems, and you're going to skip it? I don't advise you to do that, people. Okay? So I'm going to show you how easy it is. We're going to work the very first blank.
So she's giving us a lot of work.
No, this doesn't take but a second. Okay? And then I'm going to give you, huh? Yeah. Okay, so let's look at number 1. Here's what it says. Theater. A stage crew is assembling a 3-level semicircle platform on a stage for a performance. Okay, so let's kind of draw this thing. Hey, I never claimed to be an artist, right? Well, it is kind of like a cake.
Well, it was going good.
I think it's still going good. What's wrong with it?
It's going backwards.
Okay. What? Well, it is a little bit, but you use your imagination, people. I'm not Miss Kaufman. Okay. So here's what it says. The platforms have the dimensions shown in the diagram. Okay, so here was one of the problems. How tall are each one of the steps on the platform? Okay, so everybody sees that pretty well. But the other one you don't see unless you look for it or you know it's there. Yeah. How wide is it? This right here is 2x. This right here is. And this right here is. Okay? So, everybody understand? All right. A. Here's what A says. It says the platform has the dimensions shown in the diagram and a total volume of 448 pi cubic feet. Okay, so my total volume equals 448 pi cubic feet. A says, what is the volume in terms of x of each of the 3 levels of the platform? All right, so let's find the volume of this guy right here. Okay, just this top one. All right, when I say volume, most of you, your brain screams what? Does y'all do that? Does y'all go base times height? Mine goes length times width times height, okay? But yeah, that's when I say volume, my brain goes length times width times height. But we can't do that with this because it's a semicircle, okay? So let's talk about his volume. How do you find the volume of something other than a rectangular prism? Yeah, that's it. Y'all called it big B times H, right? Area of the base times the height. Well, what is this base going to be? What figure is it? It's a circle, right? So it would be pi r squared. That's how you find the area of a circle. And then we're going to measure it times h. But what do y'all keep saying to me? It's only a semicircle. So it's really going to be divided by 2. Does everybody agree with that? Okay, so let's plug in our numbers. So pi times. What is the radius of that top here? 2x. And then what do I have to do to that? Wait, first I have to square it, okay? And then I'm going to multiply it by what's its height? X. Then I'll divide it by 2. All right? So square it. What's 2x squared? 4x squared. And then multiply it by another x, and what do you get? 4x cubed. Now, where does the 4 really go, guys? Yeah, it goes in front of the pi. You don't ever say, you know, pi 2. No, you say 2 pi. All right? So, 4 pi x to the third over 2. What is it? 2 pi x to the third. That's my answer to that first blank. Okay? So can you do the next one? The next one, what's his radius going to be? Yeah, 2x plus 2x, which is 4x. When you square it, what are you going to get? 16x squared. Then you multiply by x. Now you got 16x cubed. What are you going to do with that? Divide it by 2. Come on, people. That doesn't take very long, does it? Why are you looking at me like that? Did I lose you? Yeah? See the second one? That's the first blank. Okay? The second blank is the second tier. It's the same thing. Pi times, this time it's 2x and 2x. So 4x squared times x. So there's my 16x squared. So there's my 16 pi x to the third over 2 is what? 8 pi x to the third. All right. Anybody got a question? Okay, so you can use the rest of the class time, and you can work on your worksheet. All right? I'm going to make it due Wednesday.